Good morning, everyone. My name is Ben. The title of this talk is SDLC like water. It is not a Seaworld joke. It is, in fact, it's about being fluid with your processes. Subtitles of this talk are Continuous Evolution of Delivery Processes, or, the real topic of the talk, Why are native apps so damn expensive to maintain? This is a story about maintaining a high-quality bar across a broad attack surface with a tiny team, about experimenting with and iterating on our development and release workflows, obsessing over process optimization to unlock latent human performance, and reconciling web CI/CD best practices with the complexity of UI-heavy native mobile builds. It's really the crux of my personal relationship with the last couple of years of work. The remit of my team. I'm Ben. I've been in startups and FANG and now in big publicly traded companies. I run the engineering team that builds our guest-facing mobile applications. We have 7 brands and 13 parks. Each of those brands gets their own mobile build. So there's a Seaworld app, there's a Busch Gardens app, there's an Aquatica app on iOS and on Android. You gotta be in the store. It's a branding thing. We deploy these apps to about 4 million guest phones a year with a team of 9. We're directly responsible for a small but important fraction of company revenue, and we manage vendor SaaS that drives another small but important fraction of company revenue. What do? We have a couple of platforms that we deliver, iOS, Android. We've got some JavaScript, of course. And we have a backend for front-end, hand-rolled API gateway, on-prem plus abstraction layer. Our responsibilities. Line go up. It's a very mercenary play. Don't break anything. Maybe ship a few features every quarter. Seriously and concretely, we implement funnel optimizations, improve the experience for our guests, and we unlock new sources of revenue for the company. New revenue sources would be things like ordering food online and having that print out in the restaurants, these sorts of things. We constantly work on honing our observability and systems automation. But again, don't break anything. Here's how the engineering team is laid out. I've got 3 heads on iOS, 2 on Android, 1 JavaScript front-end engineer, but also the native people pinch hit on that platform as appropriate, 2 backend/systems/DevOps people, and 1 QA. I'm not on here because technology leadership doesn't count. We're spread really, really thin, as you can see. So we support quality with all of the obvious things: unit tests, integration tests, UI flow tests, but fully automated VQA is the last gap for us. Let's talk about the quality on each of our platforms, how we approach that. For the BFFE, it's very well tested. I think we're all on the same page. Like APIs and systems like that are generally pure functions. They're easy to test. It's got fast deploys, fast rollbacks, great monitoring. This is stuff that the industry has been working on for decades. We stand on the shoulders of giants. The JavaScript Webviews, similarly, have pretty great integration tests, fast deploys and fast rollbacks, because we're just transpiling TypeScript to JavaScript and shipping that to a CDN. And it, too, has great monitoring. iOS and Android have good tests. They have reasonable UI flow testing as well. But they take forever to run. And the App Store approval workflow itself makes rollouts and rollbacks complicated and time-consuming. So we're only going to talk about the interesting things, which are the problem children. Stuff that works well is uninteresting. Quality is multi-axis for us. How is production feeling today? What are our error rates across all of the experiences that we care about? Getting code in on a good cadence, making sure that the code itself is of a high quality, making sure that the features delivered with that code are of a high quality. Testing these changes, both with automated tests and in the places where it's not practical to write automated tests, manual tests. An example of this would be our Maps application for routing guests around the park. Directions. You're in point A, you need to get to point B. I would love to sit down with you for a week and a half and figure out what tests we're going to write and what assertions we're going to make about that. And then vetting visual changes, and conversely, ensuring that changes have not occurred. Quick digression. Spot the VQA failure. A little hard to see. Maybe if you look closely, you can see it now. Even closer. Anybody see it yet? What is that? Why is that there? That's a scale bar from the map provider that we use. And we upgraded our map provider SDK one time, and they gave us a scale bar. And it took us 3 or 4 releases before anybody noticed it. That's what I have to deal with. No segue. Brief digression into mathematics. Pop quiz. What is the length of vector? QA failure. Gave the answer away. The reason that this happened is because I wrote it in PowerPoint and then shipped it to someone who transferred it into Google whatever, and then someone else translated it back into. Anyways, what's the length of vector 0, 1? Everybody all together. 1. What's the length of vector 1, 0? For those of us who have some math, the next question is obvious. What's the length of vector 1, 1? Square root of 2. Deriving the length of a vector in an arbitrary number of dimensions. We all know that c squared is equal to a squared plus b squared, right? Pythagorean theorem. In general, the length of a vector is the square root of the sum of the squares of its dimensional components. Why do we care? Let's talk about estimating the cost of quality. Granted, all models are wrong, but some are useful. Let's walk through this really quickly. So for our BFFE, rollouts and rollbacks are pretty fast. They're not as fast as our JS app because we roll in batches, and sometimes in the middle of the day, we have a lot of servers running. So it's not the fastest thing that we do. Our monitoring on it is great. Complexity, hang on, I'm missing some notes here. Oh, come on. There we go. Higher is better, is the thing to observe here. Higher is better. Complexity, in comparison to the other applications that we run, not that high. Tests, great. JavaScript application, rollout and rollback is very fast. Low cost of making mistakes here. Monitoring, not quite as great as our backend. Complexity, it's pretty complex. It's a checkout flow. It's a whole e-commerce flow. And its testing story is okay, not as good as our backend, but it's okay. On iOS, rollout and rollback is extremely painful. Concretely, you can't simply deploy a binary that you've already built on iOS and Android. Due to the cryptographic deployment shenanigans, you have to increment, recompile, resign. Monitoring is okay. Monitoring on mobile applications hasn't quite caught up to the state of monitoring on back-end applications across the industry. For both iOS and Android, the complexity is high. We have a very complicated application. And the tests, while present, are not as good. So how do we calculate this normed cost? For each of these, we basically take the inverse of dividing the vector length of its complexity cost by the least complex thing. So this shows us who our problem child is, which is iOS, right? It's slow on rollout, rollback. It's got not as good monitoring as Android. Same kind of complexity cost, same kind of tests. So that's definitely our most complex thing to maintain. So you can see, does this work? There we go. That's 1. Going down from there, you can see that the normed cost of maintaining complexity for the back end, much lower. It's a model. It's wrong. All of these numbers are made up. Don't take it too seriously. How have we been working on the build and release cycle? The build and release cycle is really where all of our time is spent. Compile the applications, test them. Does it look right? Does it feel right? There's some subjectivity in there. We've tried a couple of different things. Bi-weekly sprint releases. We've tried one merge, one release, true CD. That's the kind of quixotic thing that I would do, and I did, and it had trade-offs. And on demand. Just the 3 models that we've worked through over the last 2 years. Sprint releases. Staggered operating system releases. This is okay. means that we're not trying to do both iOS and Android in the same week at any time, reduces the labor for that. It's a very predictable release cadence, and predictability is important in business processes. What don't we like about it? Well, it's staggered OS releases, which means that every week, one team is sort of like waiting for an interrupt from QA that they need to go deal with so that they can get that build out. Some sprints don't have deliverable work, right? Some sprints have deliverable changes, but nothing user-facing. And the fixed release costs amortize kind of spikily over deliveries. We have the fixed cost, and sometimes it divides itself nicely across all of the features that we're delivering, and sometimes we run a release that has very little by way of changes, and we still incur those costs. This is me. Non-continuous processes provide nooks and crannies in which incomplete automation gets a toehold and metastasizes. Any time that you are running a process that is not the exact same every single time, that has manual steps in it, people will elect to not do those manual steps. It didn't matter last time. It didn't matter the time before last time. All of a sudden, it does matter one time, but they didn't do it because they didn't feel like they had to. Continuous deployment trade-offs. What do we like about CD? It's simple, it's predictable, you can reason about it. Code is merged, code is deployed, the world is a happy place. Continuous processes are great. Non-continuous processes are expensive. Getting people to context switch on just how they are going about their day is what's expensive about non-continuous processes. But it's difficult to block merges, and so therefore deployments on design and QA and product. What about a refactor? Who cares about a refactor? Maybe it did touch some UI-facing files, but do we need to block that merge or that deploy on the product people taking a look at that build? What about copy changes? Well, it's a trivial change. Who needs to review that? We're in a Sarbanes-Oxley regime, so we have to document when we make these changes. Other trivial changes, or changes that the engineers make because they want to make them, because it makes their life better. Making faster compilation loops, making faster test loops. These are things that are going to go into the build, that are going to produce new binaries, but they're not user-facing. Product doesn't care. QA only cares insofar as the build isn't broken. And for this model, the fixed release overhead amortizes terribly. We have the same overhead for doing a release, but now we are buying that overhead every single time we ship a new build. For example, change documentation. What changed? What's the rollback plan? Doing all of the regression for every single commit. Visual QA, think about that scale bar. For every merge to trunk. If you want to merge aggressively, if you want to maintain high-performing engineering teams, you are unlocking them to merge all day. If you are also deploying every single commit, and you have fixed costs on getting those builds out to your customers, that gets very expensive. And from experience, your non-technical people will absolutely revolt. Trunk on demand. What's good about it? You can dynamically optimize the release cost. You can say, okay, I've got these fixed costs. I'm going to wait until I have enough features in the canon that I think it's worth spending the time and energy to do a release. Engineering is unleashed to a certain degree to do hotfix and optimizations all day because they're no longer worried in the back of their heads about design or QA not approving the PR in time and the code getting merged in a reasonable amount of time. But some downsides. The unpredictable cadence of when we feel like it, driven by product, engineering, and QA altogether, negotiating that. Predictability is good for business processes. Unpredictability is bad for business processes, especially when it's a painful thing. I don't remember who said this to me, but a mentor once said, find the painful thing to do in your processes and do it again, and figure out how to make it not painful. When you have an unpredictable cadence for a painful thing, and releases in this context are relatively painful, even though they go well, they're still painful because it disrupts the normal flow of people's days. That unpredictability alone is enough to drive people to try to not do it, which increases the batch sizes of released changes, which increases the risk of any individual change. It's poison for business processes. And now QA needs to validate that literally every single change in trunk is in fact production ready. This is the cost of trunk-based CD. I had one more point there, but I think I handle it on the next slide. These approaches all optimize for engineering, not other stakeholders. Sorry, sometimes the engineers are a little bit of a narcissist. Your engineering lead can be a bit of a narcissist, optimize for himself and his team and not the rest of the other stakeholders. Every change, like I was saying, has to be perfect to merge it into trunk. Otherwise, the build is broken. And if something isn't right in the trunk, then someone in engineering suffers an interrupt and has to back that change out. And if there are dependent changes that have made it into trunk since then, those have to come out as well. Maybe changes aren't necessarily logically dependent, but they touch the same files. In the weeds here, but you can see how this is expensive. It also produced a growing queue of work-in-progress features that were either incomplete or blocked for UX review or VQA review. Does it look right? Does it actually, is the experience correct when we get it into trunk? And if it's not, well, now we're in trouble. We have to go back it all out of the build. Features could get merged into trunk and go completely unreviewed until the run-up to a release. And when your release cadence is when we feel like it, that could be a feature that was delivered, as far as that engineer is concerned, a week and a half, 2 weeks ago. And QA takes a look at it, or product takes a look at it and says, nope, categorically no. And then some engineer has to go load that feature up into their head and figure out what to do, back it out, roll it forward. These are costs. Pre-gamed this one, but trunk hotfixes during a release run-up are complicated and expensive. If you've got your release candidate and you've got a bunch of other merges after it, and you want to go merge, you want to go hotfix your release candidate, you're in a situation where you either have to push a build outside of CD or you have to pull in everything that's been merged since you cut your release candidate, or since you picked your release candidate, or you push everything out of trunk that's been merged since you cut that build. So this doesn't work. There's a lot of challenges here. We're trying our best. Engineering is really happy in terms of their own cadence and velocity, but when it comes to getting these changes out into production on iOS and Android due to the stores, we're really not hitting our marks. So let's take a step back. Let's think about what matters. Ask ourselves what we care about. What are our release engineering ideals? We want to minimize work in progress. Things should get merged quickly. We want trunk to always be releasable. Idealistic, but this is what we want. We want to amortize our per cycle costs more efficiently. And we want to reduce risk of prod breakage, at least, again, for targets with slow rollbacks, iOS and Android in my case. And we want to speed up this release and development cadence. The loops that define our business processes, we always want to speed them up, always want to be doing better. And we want to minimize complexity. These are our ideals. These all sit in tension with each other. Pushing hard on any one of these is going to make compromises on another. Here are the experiments that I'm working on to address this. We're working on Webviews, so we're pulling a lot of our UI logic into JavaScript that gets shared between the two applications. This we can deploy all day, we can roll back all day. It's very cheap to make mistakes in this context. I like to think about the cost of making mistakes. Cost of making a mistake in native code and shipping that is high. We have 7 brands. We have to cut binaries for each of those brands. That's a 10-minute process. Then someone, even parallelized, it's a 10-minute process. Then someone has to go upload those binaries to the stores, submit them for approval. It has to be right every single time. So iOS and Android are expensive to make mistakes on. Webviews are much less so. Feature flags, an experiment that we're working on. Being able to merge code all day without exposing it to the end user. Frequent and scheduled releases, bringing that predictability and that cadence back into the business process. And VQA automation. We're also doing some experiments with version control. They're kind of not super interesting to talk about. Let's talk about all of these things in detail. Feature flags. Charity Major says, releases are a terrible way to change the user experience. All right, reasonable claim, willing to entertain it. What do we like about feature flags? We can merge broken and incomplete code all day, and it doesn't affect the end user experience. It unlocks progressive feature rollout with session replay. This is magic if you don't have really robust user experience tests. The ability to find session replays for features that you're not quite sure that you've built the right thing, expose that feature to a small fraction of your user base, watch how they interact with it. This is magic for product and design. But it comes with a massive operational complexity risk. Maintaining your feature flags, keeping track of their names, coming up with a sensible naming scheme, descriptions, their own life cycle becomes a sub-life cycle in your software development process. You have your big loop of commit, test, release, and within that, you also have your features, which now span that. You can have a feature that is not done for many, many, many releases. Is someone working on it the whole time? When is that feature evaluated? So you now have loops that transcend your single deploy loop. It is a big complexity risk. And then implementation cost as well. There's a risk for implementation risk. So if you have a feature flag that manages 2 separate text fields right next to each other, you now have a cyclomatic complexity problem that you have to test the changes that you're making, and then you have to test both of those changes in all of the possible states that they can be. Both flags off, one flag on, the other flag on, both flags on. You've increased your implementation and testing cost on that. And post-rollout costs. We changed it, we shipped the code, it's in users' hands, now someone has to go turn it on and keep track of the state of that flag somewhere. Maybe in the flag management software, maybe in an external spreadsheet. There are just costs. I'm just pointing at the costs associated with this. More frequent releases. This should be easy, right? We like the predictability of it. We like the small batches. Small batches are great. What don't we like about it? We increase release-related overhead merely by virtue of doing it more often. So just releasing more often means that we buy the fixed costs of doing those releases more often. Not rocket science, but worth pointing out. VQA automation. This one is still very much an experiment in flight, but we're looking at various providers that we can ship screenshots or other artifacts to that they can run tests on and tell us when things change. We're a very content-heavy build, and we change all the time. And the company is 60 years old with 30-year-old software still in service. And getting our staging environments to look exactly like our production environments from a software perspective is doable, but it is not necessarily doable from a content perspective because our deals change all the time, and the shows that we're running change all of the time, and the events that are happening in the parks change all of the time, and the operating hours for the restaurants in the parks change all of the time. So any tests we write, any VQA automation that we buy has to account for pretty dynamic content. Has to be able to say, well, the content changed, but what about the layout? Is the layout still the same? We also want to be able to say things like, the layout didn't change, but the content is incorrect. So we have really strict standards for ourselves in terms of, for example, is this restaurant open and accepting mobile food orders? That's a call to several different systems. One system to understand the hours for the restaurant, another system that we don't even control to understand whether the tablets that are handling orders at that restaurant are even on and accepting orders, which is something that the back-of-house staff control. So VQA automation, really cool, really powerful, but our challenges are that we have an extremely dynamic business context that these apps run in. It should, in theory, reduce the cost of regression and manual QA flows. So for all of the things where we know that it's going to be the same every time, we can test this pretty easily. But for things where it's not the same every time, like did a restaurant enter into a different class of restaurant that accepts a different set of discounts? We have a different badge for that. That's the sort of thing that you're only going to identify if you are deeply intimate with the entire catalog of all of the restaurants across all of the parks, and you look at it and you say, wait, that restaurant is in the wrong category. How did that happen? Why did that happen? Is it that way in a previous build? Or is it a code change? Is it a content change? This is expensive for us. There are increased OpEx costs associated with this. So if we pay for something like this, it counts as OpEx. You can kind of fudge this with finance. You can say that it is CapEx in the context of developing new features and maintaining quality. but finance is pretty aggressive about accounting for OpEx correctly. And so automation tools like this that you don't build, but that you buy, tends to land on the OpEx side of the budget. And has CapEx costs associated with it as well. You just have to go build those integrations. You have to write those tests, and then you have to maintain them. Version control practice changes. We've updated our release pipelines so that we can make production builds from arbitrary branches. So in addition to the automation on trunk that does run, it produces a build and uploads it to Apple and Google on every merge to trunk, we also have the ability to kick off a manual compile upload cycle. Someone has to do it. It does solve the problem of hotfixes bringing in all changes, but someone has to go manually kick that off. And there's a little bit of extra complexity. Hotfixes then need to be cherry-picked back onto the trunk, or vice versa. Someone does the lazy thing, makes the fix against main, and then has to cherry-pick it back onto the commit that produced the release candidate. Identify that, do all the changes necessary to make that work. And then you've got two commits that are different doing the same thing, right? So there's complexity, just costs. Webviews. I'm a big fan of Webviews. I'm like webapp, distributed systems, CI/CD, that's my history. I like them. They've got super fast release and rollback. It unlocks us to do true CD. So features that we build in the context of JavaScript applications. We never started the timer. Changes that we make here, we can roll back trivially. We can ship all day. And in theory, you can implement once for both platforms and get the browser for free. In theory. Downsides, interfacing back with native is complex, expensive. You have to have good software engineering practices. You have to have iOS define an interface and Android define an interface, and it has to be the same interface, and then the JavaScript has to go implement it. It never feels as good. The user experience is never quite as good. It's gotten a lot better over the last decade, but it's still not perfect. And it's complicated. And as a software engineer, I am always looking at places where we accidentally introduce complexity and places where I can eliminate complexity. So while this has its upsides, it is a much more complex system than a pure native application. Trade-offs. We're all engineers, we all understand that nothing comes for free. And complexity here is the trade-off of Webviews. Preliminary results, it's just a table. You can get the slides later if you want. Feature flags are expensive in terms of complexity. They have costs. Frequent releases, there's not a lot of upside to it other than the business process stability. Version control changes. VQA automation is really going to be the big win for us, along with Webviews. So that's where we're really going to see the best wins. Webviews have already delivered some returns, but VQA automation is the other place that we should. Let's look at this chart again, or this table again. These are the places to focus on. If we think about the math that's underneath this, these are the things to focus on. Rollouts, rollbacks, and tests. These are what's going to improve the cost of quality for these two things. And to that end, VQA. This is why I'm focusing on VQA, automation, and rollout and rollback, speeding that up. Because that's going to buy me the best results on that completely made up model. More summaries of preliminary results. Feature flags are awesome. They add complexity. Production testing groups are awesome. Being able to ship software in an environment where you have very little control over staging content setup, being able to deploy changes into production and test them yourself without affecting the user experience is a superpower. Progressive rollout is awesome. Being able to expose features gradually to more and more users is awesome. Being able to turn features off at runtime is kryptonite to risk. A couple of weeks ago, last week, week before, we rolled out a new integration with a software vendor. Let me correct that. We had a stable integration with an external vendor for our mobile food ordering system. And they fixed a bug in their backend where only the restaurants for one of our brands was showing up in the API. But for whatever reason, this made their API painfully slow to load. We're talking like timeouts at 1.5 minutes. Couldn't get requests answered in time. But we had this wrapped in a feature flag. So it wasn't a release, it wasn't a rollback, we simply turned that off. Applications continued working, our latency numbers went down to a sensible place, and we moved on with our life. And I sent them a cranky email, and they fixed it. But asking the not knowing if a flag is on is total poison to the process. Is this broken, or am I not in the testing group? Is this broken, or is this flag not configured correctly for the testing group? Anywhere that there's confusion, going back to my points about cadence and predictability, anywhere there's confusion in a business process, things slow down. You get stuck in tar. Webviews so far, pretty great. These are probably my biases speaking, but Webviews so far are pretty great. Everyone loves working on them. But on the other side of that, now everybody is kind of reluctant to build features in native code. And against my better judgment, we prototyped this work against a pretty hefty feature which has been slow to roll out for reasons beyond my control. This is also delaying legacy feature cannibalization. I want to go devour the apps with this technology, but I can't until we roll this out. It's fine. We'll get there. Strategic takeaways. Shipping to the stores is expensive. It's just expensive. UI is also expensive to keep looking and feeling great. You have to spend a lot of attention to it. Think about that picture I had up there. You have to be able to catch those things. And manual VQA dominates your quality costs. So if you don't have that automated, that's going to be very expensive, and it's going to dominate your quality costs. And then the release cadence dominates your shipping costs. So if you're only doing it every 2 weeks, that cadence is going to define your ability to get changes out. That's 26 changes per year, not counting holidays, not counting people on vacation. And keep in mind that I have a team of 9 with 2 Android engineers. And if they both take a vacation at the same time, we're not doing anything. Automation is your only hope. Automate everything that you can, except that there are still going to be manual processes. Tactical takeaways. Implement visual testing as early as you possibly can. We all, I hope, do build automation at the beginning of our projects. We've learned that bolting it on afterwards is painful, and stakeholders get confused. Use feature flags, but hone your practice, because this is a practice, and you do need to hone your practice here. And consider Webviews or some other over-the-air mechanism for your business context. You could do something wacky, like shipping a Python shared API client to both platforms. You could also do something much simpler, like a WebView. You will still need an iOS and Android expert. You're never going to get away from the Cordova problem, where you build all of your apps in C#, and then you build your team around that technology, and then you don't have anybody on staff who's capable of cracking the hood and fixing interop problems with native. Thank you very much. This is what I've learned over the last 2 years. Well, more.
All right, thank you so much, Ben. And we do have time for a question or two. I have got the catchbox mic, so we're all going to be very participatory today. And then if you could progress one more slide as well, please. I do want to remind everyone to please fill out your survey as well. I think that is in app.
That's why I had to send them my slides.
Speaking to that, is that? Yep, it's right in there.
One thing that has crossed my mind as it's going through.
Closer.
Oh, okay, great. Good presentation, very good, thank you. Have you thought about implementing, or maybe you have DORA metrics, time to, deployment frequency?
I have. We're a tiny team, and I think the nature of how small we are and how fragmented we are with being responsible for a JavaScript app, an iOS app, an Android app, and the back end wouldn't give us a lot of good stat sig on those kinds of things. And at this point, I'm a seasoned enough, I'm still a relatively junior engineering manager, but I'm seasoned enough that I can look at the teams and how they're doing and be like, So I don't need it yet. My remit is not quite so broad that I need that kind of perspective. You can also just yell.
Thank you.
Hang on, you missed your chance. Someone else has the ball.
Sorry.
Go.
Okay. So I came a little late, sorry about that, but I saw something mentioned as session replay.
You saw some session replays?
Yeah. Is that the whole user experience recording in a way?
Yeah.
Are there PII implications to that?
What do you mean API implications?
PII, not API. Like, you might see some information that you should not be seeing.
Oh, for sure. Oh, yeah. You got to work with a provider that is going to help you do that setup and mark out the fields that you don't want.
All right. Thank you.
But at least for our context, I think all of the session replay providers do a really good job of identifying email fields and human names and credit cards out of the box. So that's much less of a concern.
All right. So there are inbuilt some sort of masking at least.
Yeah.
Oh,
If you're going out looking for that kind of tool, like definitely look at their PII censorship out of the box.
awesome. Thank you.
Many will even do some wacky crypto thing where you can have private keys that can decrypt those session data. So they receive it encrypted to your business's keys. And then in your sessions, you can, and then you have to like cross your fingers and trust them. You can either dump your private key in or like decrypt the value and get them to render it in the session replay. But it's generally not super material.
Thank you.
The best way to deal with PII though is to like get the scope of what is considered PII or like sensitive data trimmed down as much as possible. It's the same trick for doing like handling cards. You just like reduce the surface area for compliance as much as you can.
But could you not like mark certain screens or certain fields maybe at the code level as, hey?
Sorry, there's an echo. I'm having trouble.
Oh, no worries. Is it better now?
Still can't hear.
Is there no way in code that you can mark certain fields that even if there's a session replay,
like-
don't record these at all or blur these out as such?
Yeah, there are. The session recording tools definitely have the ability to say like this field is PII, don't reveal it.
Cool.
They do. I hope that answered your question. I hope I
Thank you.
understood what you were saying.
I think we had time for just one more, and then we're going to go ahead and wrap over to the next one. Somebody had their hand up here first. Okay.
Thanks. So when you're deploying apps to mobile devices, do you care about the settings on those devices? Like for your use case, it may be end users, but for others, it's like a retail device, like a mobile iPad checkout for something like that, for like retail food and beverage. Have you guys ran into the problem where settings on the device impact the functionality of your application?
Yes. Text sizes.
Yes, that's a big one.
Text sizes are a big one. Our content editors don't really think about the length, and we don't have a good way. You can think about it as another deploy loop, where the content editors are going to make changes to the content, images, descriptions, all of these things. And how is that going to get rendered on the screen? Usually, we've got good guidelines in place for them, but even with us, we have like these device sizes that we care about and we have the bandwidth to test for, and then these text sizes that we have the bandwidth for thinking about.
So when there is something that's found, like a device is misconfigured and something is wonky, like an outlier, how do you guys maintain that?
How do I say this as politely as possible? We try to be pragmatic about the scope of what we want to tackle. And always in the back of our minds is like impact, right? Like thinking about text sizes. Yes, it would be great if grandpa's phone rendered the app a little bit better.
Right.
But let's take a quick look at the demo of the users of the app. Okay, grandpa's not actually that, like the demo of people that need huge text sizes is not that big. We have these other projects that are gonna unlock like, $200,000 a month or, a couple $1 million a year. And that's how we think about that sort of work. We also have accessibility rules that we have to hit, so there are guardrails on that process.
Thank you.